Next in the series is evidence of execution. The This part focus on providing the program actually ran on a window host. Prefetch, Amcache, ShimCache, and BAMDAM are the core artifacts. So these are important tools. Parsed primarily with the Eric Zimmerman tools. For example, finding malware.exe on a disk is interesting. Finding prefetch that says it ran 14 times last night is case changing. So here are tools like Amcache is a registry hive under Windows app compact programs that store application file inventory metadata including full path and often SHA1. Tools like AmcacheParser in a Amcache shows C temp steel.exe with SHA1 starting with some hash value like ABC123 and so on even after the file was deleted from disk. So it's an important tool. So likewise, there is another important tool called ShimCache, which has a compatibility cache stored in the system registry hive, listing paths that were executed or otherwise referenced. Timestamp are limited. OS dependent, but presence and order helps. So tool like AppCompatCacheParser are useful. Inside ShimCache list see user public update.exe nearby explorer.exe activities around a phishing click. So these concept for the timing is just to remember, and the tool name is important to remember. Very soon I'll prepare the hands-on practice on these tools and upload as well. So presently giving an introduction to the tools and a little bit about their importances. So in this part, you will be able to explain why execution evidence matters. Compare the four major artifact classes. Read investigator critical fields. Follow collaborator flowchart and practice um, PECmd, AmcacheParser, AppCompatCacheParser, and later registry parsing. So here I'll give just the theoretical introduction to these tools, but in later lectures in this series I will do the hands-on practice as well. So example includes like producer CSP from PECmd tool and identify the last run time of chrome.exe plus reference download paths. Now, why execution artifacts matters? The left text stress that the execution artifact elevates confidence beyond file existed. User cases include malware confirmation, lol-beans abuse, insider tooling, and ransomware staging. The right flowchart, file on the disk, lead to execution, which further lead to evidence and which finally lead to high confidence is the teaching hope. For example, certutil.exe on every window disk is normal. Prefetch showing certutil with a URL and output file path rather an alert is suspicious. The four boxes introduce prefetch, Amcache, ShimCache, and BAMDAM, followed by a comparison table of strength and limitations. Prefetch is rich but often disabled on servers. Amcache give path and SHA1 values. ShimCache is a longer list with weaker times. BAM is a stronger last run per user on Windows 10 plus and Windows 10 and higher. For example, on a server to 2019 box with prefetch off, do not stop pivot to uh, Amcache, ShimCache, EVTX 4688. So here there are three things which we have to note down. First thing is the location, the path. C window prefetch. The second is the naming. Any file name with extension of .pf. And the third thing is the contents. The contents includes run count, last runs, reference files or directories. The C Windows Prefetch folder is a Windows system directory designed to speed up your computer. It tracks how often you open application and store that data as traces file, ending with the .pf, allowing Windows to load a frequently used program much faster. Prefetch files are automated trackers that Windows use to help your computer load application faster. When you open in program, window watches which file and folder it need to start up. And remember that list for next time. To keep track of these records, Windows names the file using the program names followed by a unique 8-digit code, the hash. This code is based on the program exact location on your computer, meaning that if the same program is run from two different folders, Windows will create two separate tracker files. Inside the prefetch files, Windows store a lot of information or the history. It keep an exact tally of how many times you have opened the program, along with a list of exact dates and time for its most recent launch. It also save a complete list of every background files, folder and system component that program interacted with during its startup phase. Because these files record exactly when, where and how a program was used, digital investigators frequently use them to prove what actions were taken on the computer. Now here PECmd is an important tool or command for practice. So like notepad.exe and some name dot with an extension of .pf, last run on specific date with reference path, um, support that notepad open that file around, then not proof of content but strong activity evidence. So here PECmd is a Eric Zimmerman's prefetch parser. So with -dc Windows prefetch tells it to scan that folder for all PF files and Windows record of which program run, how often and when, and with double hyphen csv cout write the result as csv into the cout, and double hyphen csvf pf.csv name that file pf.csv, so you can get the single spreadsheet of executable names, run counts, last run times and reference files ready to open in a timeline explorer. Just now we executed the uh, PC CMD command, and it has created two files, PF files and PF timeline files. So you can see the PF files, and you can see there are a lot of data it has generated. Now we can do a lot of experimentation with this file, which we'll do in subsequent lectures. But I'll give you an example. Like you can see the last run. So last run files you can see, and you can sort out the data. So by sorting the data, um, you can um, you can find out what are the recent activities has happened in the windows. So this is one way you can observe the windows. So likewise we have PF timeline as well. So as you can see, the PF timeline file is giving the timeline, the runtime, at what time it has run and which program has run. So another set of important information you can get from this file. Now the decision tree here, you can see how the forensics works in Windows. It search prefetch for the suspected exe file, and whether the prefetch is found or not, so it will work accordingly. If the prefetch is found, then it has to record the last run count, and embedded path. Now if prefetch is not found, then we have to use the other tools like Amcache and ShimCache and BAM. So both path finish by correcting with MFT created time. So use ln key files and evts if available. So this replaces the confusion of run count greater than 0 fork. So a prefetch file almost always implies execution. For example, the ransomware.exe has a prefetch run count of 1, and reference file is in finance share folder, and MFT shows the exe created 2 minutes earlier drop than execution. So this shows how the Amcache and the ShimCache will help later if prefetch is not found. So Amcache.hve for program inventory file enters the path publisher SHA1 and first seen via the AmcacheParser. ShimCache is system live hive via the AppCompatCacheParser for executor reference pass and insert order. The merge diagram pushes both CSP into the timeline explorer. So Amcache, for example, the Amcache SHA1 of the payload.exe file, some payload executable file matches the virus total malware. So ShimCache shows it adjacent to winword.exe after a phishing document open. So both are confirming this is malware. Now you can observe here the three tools PECmd, Amcache and BAP. All three are important tools. So the BAM background activity navigator store last execution under user SID keys on modern Windows. Excellent user attribution. The flow user SID BAM entries file time exe path shows the logic. Practice with the Registry Explorer or RECmd batches. So for example, BAM under SID ending is giving some data ending with 1001 shows C Windows some location like C users Bob download tool.exe at some time like 19.0 time 02 UTC trying execute to Bob rather than a service count. So these kind of activity could be observed in a BAM. So I'm not showing the execution scenario using BAM and other tools, but later we'll do this practice. So here the color matrix teaches do not trust any single source. Prefetch BAM are strong for did it run. Amcache is best for hash path. Prefetch lack hash. BAM lack hash. For example, the courtroom style statement, if you can see, the prefetch and BAM independently showed last execution of steel.exe, some executable file, whereas Amcache provide SHA1 for some data. Together, confidence is high. So if you are using two tools like Amcache and prefetch and BAM, so they are giving a favorable result. Whereas the other side, the ShimCache timestamp is ambiguous. So ShimCache is not supporting it. So if two tools are supporting, especially the Amcache and BAM, then it's a good proof. So here you can see like the experiment we perform and the theory topic we discuss. They are different tools. So like PECmd we executed and we get a lot of information about the file which open and the directory locations. Now there are other tools also like AmcacheParser. So this can also confirm the path and provide the SHA1 informations. Like AppCompatCache also give the order of indicator of compromise, incident of compromise, and then BAM via RECmd also give the information about last run under suspect SID. So likewise, there are many other tools which we need to practice, need to consider the scenarios and which we need to practice. So today we just see the initial scanning using PECmd, but in later scenarios we will use all of these tools to develop a case study and compare the outputs. So what is the takeaway from this? So existence is not equal to execution. So collaboration server may lack prefetch, practice EZ tools daily. So like PECmd tools which you have seen is giving the timeline. So BAM um, is like a similar one, same minute for, but it gives the path information. So path can be verified with PECmd as well. So Amcache provide SHA1, like, which, like for example, you can write a three bullet finding with UTC times and evidence file pass. So such practice we can do with these tools.